Hello, good night everyone. So today is our last part in 5 session for storytelling. So today we will discuss about Terraform Mars. And yeah, we will start now. The first person is Azriel. Okay, Azriel, can you?
Yang
Okay, Teraform Mars. Next. Mars is the fourth closest planet to the Sun. Its name is taken from the Roman god of war, Mars. This planet is often called the red planet because it looks reddish from a distance. This is due to the presence of iron oxide on the surface of Mars. Next, terraformation of Mars is a hypothetical process in which the climate of Mars and the surface will be deliberately altered to create a rock hospitable area to support human life. Making Mars colonization safer and more sustainable. Some of the terraformed concepts have been proposed. Some of the proposals require high technology and are expensive, while other compete require lower technology which
jalur bapakmu. Ganteng.
nggak future human population growth, availability of resources, and alternative options that may be used as a substitute for Earth in the event of a major disaster. Besides Mars, other alternatives are the Moon and several other planets in the solar system. In some ways, Mars is the planet most similar to Earth than any other planet in the solar system. It is estimated that at the beginning of the development of the history of the planet Mars, this planet was on like Earth with abundant atmosphere, pressure, and water, which eventually Mars lost atmospheric pressure and water several billion years ago. Challenge and limitation, gravity and low atmospheric pressure. The surface gravity of Mars is only 38% that of Earth. Mars has a CO2 pressure in the atmosphere of only about 1%. The pressure at Earth sea level 3 or be enough CO2 in the form of ice in the regularity and soluble of Mars by 30 to 60 kPa. If the cold be released by warming the planet, the reappearance of liquid water on the Martian surface
Cok
more
ngomong ngono
thanks to
ae.
warming effect and density of the atmosphere, but Mars' lower gravity requires 2.6 times the mass of Earth
Nang aku nek kucing lan.
air core
Kucingku lanang pisan.
to generate at least 100 kPa of surface pressure at the now Polaris to increase
Mandiri iki.
the density of the atmosphere must be split
Iya,
for
iki sih
outlet
sing
source
metode teko tangga
such
mati.
as this melting some of the large asteroid containing
Apa bocor?
ammonia
Iki lho piye?
as a nitrogen source. Next.
Cek enak mundur-mundur, Mas. Betul, Mas.
Okay, thank you, Azriel. And the next person is uh, Arya.
Occupancy. According to modern theory, Mars is on the outer edge of the habitable zone, the region of the solar system where life can exist. Mars is at the boundary of a region known as the extended habitable zone, where liquid water on the surface might be support if concentrated greenhouse gases called increased atmospheric pressure. Next. Okay, next. The lack of both magnetic field and geological activity on Mars may be a result of its relatively small size, which allow the interior to cool more rapidly than Earth's. Although the details of the process are still not well understood, experts estimate that Mars on had an atmosphere very similar to that of Earth during its early state of development, and that the pressure-powered liquid water that was abundant on the surface. Although water appears to have existed on the surface of Mars, water ice appears to exist at the poles just below the planet's surface in permafrost. Next. The soil and atmosphere of Mars contain many of the key elements essential for life, including sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon. Large amount of water ice are found beneath the Martian surface, as well as on the surface at the poles, where it's mixed with dry ice and frozen CO2. The large amount of water located at the south pole of Mars, when melted, will fill the planet's vast ocean with a depth of 12 meters. Next. Frozen carbon dioxide, or CO2, at the poles sublimes into the atmosphere during the Martian summer, and small residual amount of water are left behind, with fast wind blowing across the poles at speed approaching 400 kilometers per or 250 mph. The occurrence of this seasonal wind transport large amount of dust and water vapor into the atmosphere, forming Earth-like cloud. Most of the oxygen in the Martian atmosphere is present as carbon dioxide or CO2. The main atmospheric component, molecular oxygen or O2, is only present in trace amount. Large amount of elemental oxygen can also be found in metal oxides on the surface of Mars and in the soil in the form of nitrate. Next, next. Analysis of soil samples taken by the phonic lander revealed the presence of perchlorate, which is commonly used to liberate oxygen in chemical oxygen generator. Electronic electrolysis could be used to split water on Mars into oxygen and hydrogen if sufficient liquid water and electricity were available. Next,
Oh, okay, I think it's enough for you, Arya. Thank you. And next person is Putra. Can you help me?
Okay. Progress method and strategies. Okay, next. Thermoforming. Mars will require their ongoing change. Will the atmosphere keep it warm and keep it from being lost to outer space? The Martian atmosphere is relative thin and has very low surface pressure because the atmosphere is mostly composed of CO2 and no greenhouse gas. Once Mars started to heat up, CO2 could have to keep heat energy near the surface. In addition, as it warms, more CO2 must enter the atmosphere from frozen rivers at the poles, increasing the greenhouse effect. This means that the two processes of building up the atmosphere and heating will add one more, supporting terraforming. The next, carbon dioxide sublimation. The next, there is an abundance of carbon dioxide, CO2, in the form of the dry ice at the south pole of Mars and absorbed by rhyolite soil on Mars. If sublimed to gas by just a few degrees of climate warming, will increase atmosphere pressure by 13 kilopascal, 0.13 atm. No, in the citation given is comparable to height of the summit of Mount Everest, where the atmosphere pressure is 13.3.7 kilopascal, and 0.13.3 atm. Okay, next. While the world may be softened for a human to breathe, being above Atmos strong limit, it would be sufficient to eliminate the need for pressure protective clothing. Phytoplankton can also convert CO2 into oxygen. Import of ammonia. Another More complicated method use ammonia is a potent greenhouse gas. It is possible that large amounts of it exist in frozen form on mirror planets orbiting outside the solar system. It is possible to aim and send them into the Martian atmosphere. Since ammonia and NH3 is mostly hidden in target. It can also supply a buffer gas for the atmosphere. Smaller, sustained impact will also contribute to increases in temperature and atmosphere mass Mars. Next. The need for buffer gas in talents that will face potential atmosphere boulders on Earth. Nitrogen is a major component of the atmosphere, making up 7% of the atmosphere. Mars will need the same gas buffer component to not as much. Okay, next. Im- Import of hydrocarbon. Next. Another way of creating a Martian atmosphere would be to import methane, other hydrocarbon, which are common in Titan's atmosphere and on its surface. Methane could be released into the atmosphere where it would act as a greenhouse effect compound.
Okay, thank you, Putra.
Okay, thank
Next,
you.
last person is Alvin.
The use of fluorine compounds. Next, because long-term climate stability will be necessary to sustain the human population. The use of fluorine and greenhouse gases may include superhexafluoride or halocarbons such as chlorofluorocarbons and perfluorocarbons. These gases were proposed for introduction because they produce a strong greenhouse effect as a greenhouse gas emission thousands of times stronger than CO2. This could considerably weaken the landing rocket with a compressed payload on a collision course with Mars. When the rocket reaches the surface, they release their payload into the atmosphere. A state barrage of TFG rockets would need to be maintained for at least more than a decade while Mars sinks seriously and gets warmer. However, their lifetime due to population would require an matter of 117 kilotons, and they would destroy the ozone layer. Next, the use of orbital mirrors. Yes.
Mirrors made of flat film coated with thin aluminum could be placed in orbit around Mars to increase the total insulation it receives. This would direct sunlight toward the surface and could increase the surface temperature of Mars terrestrially. The mirror can be positioned as steady using its effectiveness as a solar cell orbiting in a stationary position. Released to Mars near requires to separate the gas to impermeable and contribute to the greenhouse effect. Next, comet collision. Another way to increase the temperature could be to direct small comets to the surface of Mars. This could be accomplished through the use of the spacecraft laser to change its trajectory or other methods proposed to avoid impact. So its collision energy is released as much as that effect can release CO2 or possibly water vapor from the heated ice. This is also a greenhouse gas. Comets can also be selected by their composition as ammonia, which would then diffuse into the atmosphere on impact, adding greenhouse gases to the atmosphere. Okay, next.
Okay, thank you, Alvin, for
Okay.
helping me. Okay, guys, the last is thermodynamic terraformation. The thermodynamic terraforming of the overall energy required to remove CO2 from the South Polar ice sheet was modeled by Zubrin and McKay. Increasing the polar temperature by 4K would be needed to trigger the greenhouse effect. If using orbital mirror, it is estimated that 120 years would be needed to produce a mirror large enough to evaporate ice. This is considered the most effective method, although it is at least practical. If using strong holocarbon greenhouse gas, order of 1000 new years would be needed to achieve this warming. Although it is not effective in comparison, it is considered the most practical method. Impacting asteroid, which are often thought of as synergistic effect, would require about 10 billion ton ammonia-rich asteroid to trigger the greenhouse effect, amounting to an 8-degree increase in temperature. Okay, thank you guys. Uh, Before we close our meeting today, we want to ask about that topic. No one? Okay, I think that's enough for today. So thank you guys for joining this meeting. See you next time.